review next week, all of this again. So last section is 8.1, sequences and summation notation. We're going to start with the summation notation first. See what it means. Let's suppose we have the following sum of numbers. Let's say 1 to the third plus 2 to the third plus 3 to the third plus 4 to the third plus dot 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 plus 20 to the third. How many terms do I have? 20 terms. Perfect. So this is the index for the first term. When I is 1, I get 1 cubed. When I is 2, I get 2 cubed, and so on and so forth. When I is very good, I get 20 cubed. We do not like writing anything like this. We like writing it condensed. The letter we're going to use is a Greek letter, sigma. Greek letter S or sigma. This is very appropriate for what we're trying to write. The Latin S, for example, is not going to be a good fit for what we're trying to do. So this symbolizes sum. So this tells us that it's a sum of terms. From I equals 1 till what is the last one again? Very good. This is called upper limit. And this, number 1 here is the lower limit. And I is called index. From I to the third power. The index, normally you're going to find it as I, K, or J. Any letter works fine. But we normally write I or J or K for index. I've rarely seen it in A, B, or C, or D, or G. So these are the usual letters used for the index. Okay, so now let's go backwards. Let's open on page. We're practicing the summation notation for a moment. So let's say problem 46. In 46, one more example like this and then go backwards. 5 plus 5 squared plus 5 cubed plus 3 dots, exactly 3 dots, 5 to the 12th power. They say this: express each sum using summation notation. Use any index you like. You can use I or J or K, it's up to you. So obviously this is a sum. From the first term, I equals what? This is the first term. It's 1 indeed. From I equals 1. Till what is the last term? How many terms does this sum have? 12 indeed. And what is the general term, we call it? 5 to the I. So when I is 1, we get 5. Plus, the sum says plus. When I is 2, we get 5 squared. When I is 3, we get 5 cubed. 5 cubed. Blah, 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 blah. Till the last term, the upper limit, when I is 12, we get 5 to the 12th power. I know we need to practice some more. Let's also look at, let's say, 50. Same page, 752. I forgot to write. 752. Okay, so, and then I'll let you choose if you want. 1/3 plus 2/4 plus 3/5 plus 3 dots plus 16 over 16 plus 2. They want us to write the summation notation for this. Okay, no problem. Let's identify first how many terms does this sum have.
16.
Indeed, 16. From I equals which one?
1.
Yes, those terms, the sums, don't have to start at 1. But this one, like the ones we looked at, start at 1. Good. So now what is it? What do I write here? First of all, there are all fractions, right? So this must be a fraction as well. So what would be the top? Let's start with the top first.
16 plus 2. 1.
You mean I, right?
Yeah.
Yes, when I is 1, this will be 1. When I is 2, this will be 2. When I is 3, will be 3. Dot, dot, dot. When I is 16, will be 16. Now let's identify the bottom.
We put it together.
I plus 2, indeed. When I is 1, I get 3. When I is 2, I get 4. When I is 3, I get 5. When I is 16, I get 16 plus 2. Any questions?
How do we get the bottom? 5 plus 2 again?
16 plus 2. I plus 2.
Okay.
When I is 1, you get 3. When I is 2, you get 4. 2 plus 2, 4. When I is 3, you get 3 plus 2, 5. And the last one, 16 plus 2. 16 plus 2. Better? Yes?
Can you do one more?
Yes, of course.
This one.
Let's say 52. And 52, we have 1 over 9 plus 2 over 9 squared plus 3 over 9 cubed plus dot, dot, dot plus n over 9 raised to the nth power. And they want us to do the same. They want us to write the summation notation that condenses all this. And we don't write it like that on an entire row, but we just write the condensed summation notation. From I equals 1 till, very good. They're all fractions, so of course the general term must be a fraction.
So is it I over?
What is at the top?
I.
Excellent. What about the bottom? 9
To the I.
to the raised to the I. Very good. Awesome. Great job. Any questions? Any questions on this? Okay. Okay.
Yeah. Nope.
Okay, 51. So 4 plus 4 squared over 2 plus 4 cubed over 3 plus dot, dot, dot plus 4 to the n over n. Summation notation, sigma, from,
So I equals 1.
yes, till
4 n. 4 I.
till n, very good. From a fraction, which one? If I put I, if I put,
It's 4 to the power of I.
very good, over,
What's the I?
very good. When I is 1, I get 4 over 1. When I is 2, I get 4 squared over 2. When I is 3, I get 4 cubed over 3. Is that clear?
Yeah.
Excellent. Very good. Okay, so now let's go backwards finally. Let's say, I'm looking at 34. Rachel, any question?
No, I was just joking. I just got this down now.
Yes. Not difficult. This was more difficult to come up with a summation notation. Now we're given the summation notation. So k equals 1 through 4 from k minus 3 times k plus 2. Now, first of all, let's identify how many terms. Let me ask the question. Find each indicated sum. So first of all, can you please tell me how many terms does this sum has?
4.
How many terms does this sum have? 4 terms. Is that clear? When k is 1, when k is 2, when k is 3, and when k is 4. I would like to write out those terms. I want you to give me 4 terms. Don't calculate anything. I want everyone to see them. What will be the first term?
K minus 3. K minus 1.
Y minus 3, 1 plus 2, plus 2 minus 3,
2 plus.
excellent, plus
3 minus 3.
3 minus 3,
3 plus
3 plus 2, and the very last term,
4 minus 3.
4 minus 3, and 4 plus 2. Awesome. Is this clear? Is everyone clear?
I feel like I get it. I'm just gonna.
Good. Very good.
So K is that's the
No. We have not finished.
that's the index. K is the index,
Correct.
and that's why we just replaced 4 numbers in like the chronological order, kind of, because it just.
It isn't. I mean, k equals 1
Yeah,
through 4. So k is 1, 2, 3, and 4. Of course. Yes. Good. 1 minus 3.
Negative 2.
Negative 2 times 3.
Negative 6.
Perfect. 2 minus 3. And negative 1 times 4. Very good. 3 minus 3. 4 minus 3.
1,
1 times 6.
6.
Let's do this with the graphing calculator now. Ready? Don't cry. Some of the calculators do not have this. So we go to math and go up to number 0 if you have it, which is summation notation. So go up to 0 and press enter. So what is the index, the lower limit?
1.
Yes, so we don't have k, so it's k equals 1.
X equals 1.
Yes, we don't have k. We have to write x equals 1. And top, how far do we go? 4 indeed. Now keep the parentheses. Keep the parentheses. Do not delete the parentheses. And put parentheses again. X minus 3. Close the parenthesis. Open another parenthesis. X plus 2. And close this parenthesis. When I press enter, what should I get?
6.
Negative 4.
Excellent. So I press enter, and we get negative 4. We had at least one to do by hand, so we understand what's happening. But yes, you can use the graphing calculator.
What happens when you have an edge problem?
You cannot. You cannot use the calculator. Good point. Okay, let's look at another. Let's say 36. We're given the sum from I equals 2. As I said, I doesn't have to start at 1. I equals 2 through 4. From negative 1/3.
Can you put your paper back on?
Oh, sorry.
We'll go to a different one.
So we want to find the summation or the sum, the sigma notation or summation notation or sum, if you want, from I equals 2 to 4, from negative 1/3 to I. So now please tell me how many terms will we list? 3 terms, very good. Can anyone give us the first term with no calculations whatsoever?
Why 3 terms?
2, 3, and 4. I don't have anything else.
So the first one is negative 1.
Third,
3, so the second
plus,
plus negative 1.
plus.
Plus.
That's it. We don't really like to add these, but let's try. So 1/9 minus 1/27 and plus 1/81. 81 is the least common denominator. Here's a 9, and here's a 3. So 9 minus 3 plus 1. 10 minus 3 is 7. 7 over 81. With a graphing calculator. Ready?
No, wait. Okay.
You said you found the LCD, right?
I have to.
Okay.
I will not be able to add them if I don't determine the LCD. Ready? Okay, so go back to second. I just copied.
So what is it again? So how do you get that? You said the calculator has it.
It's math 0, second math 0. Or just math. If you have the TI 83.
Okay. Second man.
It may not work. I have to look at your calculator.
Yeah.
84. Yeah.
Okay, so we have -1 divided by, I need parentheses again. Careful here. Parentheses, -1 divided by 3. Close the parenthesis, caret x, and then delete the rest. If you did what I just did. Okay, and press enter. So I go to math, and I want this to be changed into a fraction. And the fraction is 7 over 81. Any questions?
What, how did you do the answer for? To get answer of the function?
I go to math, and I press the top one that has fraction.
Oh, okay. And then.
Is this okay, everyone? Yes?
No. I will.
Which part?
I don't know. I can't do it on here.
You don't have the summation notation?
I had no. It's on here. Okay, man. Right. You said pick that one.
You're talking about fractions, or you're talking
Right.
about the summation notation?
What did you say about fractions just now? You said pick the one that said fractions, right?
So we determine the answer. We have the answer. Once you have the answer, then you're trying to change this into a fraction.
Okay, so I can't. How do I input it in here then?
So you have x, and then you have 2,
Okay.
2. After x, on the right hand side, 2,
I'm trying to do this. Okay.
2, and the top is 4. And I'm inside parentheses, another parenthesis, -1 over 3, close the parenthesis, caret x.
Carrot. Oh, that's this thing. Right?
Yes, the power.
Okay.
Yep, yep.
Is this like everything?
Oh, I still have a little bit. Yes. Any questions?
Equals that, and then after you do that, then you said second. I mean.
No, you go to math and press
and then
enter.
line. Okay. Okay.
Better?
Yeah.
Good. Very good. Okay. Factorial notation. Factorial notation. Ready? Well, there is something called factorial notation. For example, 4 factorial is the product of the first 4 natural numbers. 4, 3, 2, 1. 4, 4 minus 1, 3 minus 1, 2 minus 1, and I get 1. Yes, it is. It is. Yep. So, for example, 9 factorial would be 9 times
8, 7, 6.
times 1. Very good. What about n factorial?
N squared. I mean,
N times,
is it n squared?
but did I square this to get 8? No.
Oh, n times.
So n minus 1.
Very good.
It's literally gonna go down.
Dot, dot, dot.
Right?
3 times 2 times 1. Is that clear?
Yeah.
Perfect. Now, also, 0 factorial is considered 1 by convention. You can say, but what about 1 factorial? That is 1 as well. It may look a little bit weird, but by convention, 0 factorial and 1 factorial are both 1. Okay, so now let's take a look at simplifying 25 on page 752. And we have 16 factorial, everything divided by 2 factorial, multiplied by 14 factorial. We'll do this with the graphing calculator as well, but let's do this by hand first. Ready? So how will you write 16 factorial? Can anyone dictate?
16 times 15.
Correct. But look at this one.
Oh.
2 factorial is 2, and then 14 factorial. What do you think I'm going to do? And why did I stop at 14? I simplify by 2, and I get 120.
Could you explain this just one more time?
Sure.
'Cause
Yes, so it's 15 times 8, which is 120. So I start with 16, first of all, because 16 is bigger than 14. And I know that 16 is factorial is 16, 15, 14, blah, 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 3, 2, 1. Also, 14 is 14 times 13 times 12, blah, 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 blah. So then these factors will go away. The 14 to 1 and the 14 to 1 will go away. But why would I even write them? I see 14 factorial, I see 14 factorial, I stop. These numbers, all these this product and this product will go away anyway. So then 14 factorial with 14 factorial go away. 2 factorial is 2. The top, I still have 16 times 15. I'll simplify 2 and 16 by 2, and I get 8, and 8 times 15 is 120.
Okay.
So how do I do this with a graphing calculator? So with a graphing calculator, we write, sometimes this will exceed the memory. So we have to simplify, but let's say we don't. So the numerator is 16. Go to math and cross over to probabilities and choose 4. Probabilities and choose 4. And you get 16 factorial. Now you divide, but you have to use parentheses for the denominator. So 2 factorial, go back to math and probabilities. And then 4. And then times. And we have 14. Go back to math, across to probabilities. And then factorial, which is 4. Close the parenthesis and press enter. When I press enter, what should I get? 120. Yes.
Were you this right here when you said it crossed out? Is that a 1?
Of course. Every time I divide 14 factorial by 14 factorial, I get 1.
And
Here,
you
here. You had 8 up here.
Yes.
Oh, 8 times 15.
so we can still use it again. I mean, well,
It's 1.
I mean, like once you divide 2.
So you when you divide, you get 1.
No, I'm
That's what I
talking about
wrote.
2 into 16.
Yes, yes. So you simplify the top by 2 and the bottom by 2, and you get 8 times 15, which is 120. Of course, the denominator is just 1. 2 divided by 2 is 1. 16 divided by 2 is 8. And then 8 times 15 is 120. Is that better?
I'm just about to write it out.
Oh. Sure.
So it's 8 times 15 over 1, and then it's 120.
Correct.
Okay, there we go.
Okay, so let's take a look at 41. The sum from I equals 1 through 5 from I factorial over I minus 1 factorial. Yes, we're asked to find the sum, but I will still would like to list, how many terms will we have to list?
5.
5 indeed, but I want to simplify what's inside the summation notation, which is the general term. I want to simplify it. So the sum from I equals 1 through 5. And now please tell me which of the two, top or bottom, is bigger? Well, of course we do. If you have $10 and I have 10 minus 1, of course we know which one is bigger. Right, right? I must be bigger than I minus 1. Is that clear? If you have 10 and I have 10 minus 1, then I have 9 and you have 10. So from these two, the top is bigger. So please tell me, what would you do then? How will you write I factorial? Keeping in mind that the denominator is I minus 1 factorial.
Will you write the same thing?
I times
I minus 1?
I times I minus 1 factorial. Awesome. Over I minus 1 factorial, of course. You will stop when you see that the denominator already popped up. Great job. What do you think I'm going to do now? Right, I'll simplify this and write 1. I'll simplify this and write 1, which is much easier to handle. I hope you agree. I equals 1 through 5 from what? Indeed, just I is left. It cannot be 1. However, it can be 1. Sometimes it can be, but it's not. So can you please list the 5 terms for us? When I is 1, there is no more I. When I list the terms, I has to go away.
1.
When I is 1, what do I have?
1.
1 plus. When I is 2, what do I have? 2 plus.
3.
Yes?
4.
Yes? Indeed. So 5 plus 5 is 10, 14.
So because it's just I, that just means that we just add it.
When I is because of the summation notation. The summation notation says add. Correct. Yes. Exactly. So you start with I equals 1, but you have to end with I equals 5. That's why I always ask you from the beginning how many terms we write. So to establish that from the very beginning. Yes, Priscilla?
I still don't get how you, like, why you multiplied, like before you could cross the I minus 1, and you had to multiply something, like.
If I have instead of I5 factorial, how do I write it? Don't I write it as 5 times 4 factorial? That's what I did. I factorial is I times the next one in line factorial. 5 is 5 times the next one in factorial. So this is I factorial is I times the next one factorial. If I want to write one more, I will write I minus 1, I minus 2 factorial. But I don't need to go to I minus 2 because these are the same. So I have to stop at I minus 1.
I have a question about
Sure.
the end really quick.
Is that clear?
Well, so, okay, so if the bottom was I minus like 5, you would like keep going.
Exactly, till I get to I minus 5. Of course. Well done. Yes, absolutely. So if I have the top, which is I factorial, and this is I minus 4 factorial, I will have I minus 1, I minus 2, I minus 3, I minus 4 factorial over I minus 4 factorial. And I have all this left. Exactly. Well done. What a perfect example. Yes, Charisse, you had a question.